Okay, so time to finally get to talk about supply. So we've gone over these ideas of demand and, well, what changes in price due to the quantity demanded. And now we're going to get into, well, what do changes in price due to the quantity supplied? Now, I don't want you to get confused because quantity supplied is how much producers are willing to supply a good at a certain price point. And so supply is related to the producers, demand is related to the buyers. And so there is a positive relationship between price and quantity supplied. So, if the price of a good is higher, then suppliers will be more willing to supply a higher quantity of that good because you want to supply more of something if it's at a higher price, right? Because then you're getting more money when you have more of the units that you are producing. Whereas if you have a lower price, then the producers are not going to want to produce as much. So this is called the law of supply. So if I go ahead and just there it is. So this positive relationship shows the cost benefit analysis of rational suppliers. So remember, we talked earlier about how demand, it is the result of cost benefit analysis of rational decision makers, just like the law of supply does. Apologies, it's kind of messing with me here. So we can go ahead and use this example of gasoline station owners. And so they look, okay, each gallon sold has an opportunity cost of their time, effort, and the supply, the expense to supply that gasoline. And then if that price rises, if the price of the gas rises, then they're going to be more willing to devote more resources for that gasoline. And therefore, so long as that price they receive exceeds the opportunity cost, then they'll be willing to supply the gasoline. So if the opportunity cost is lower than the price, then they will be willing to supply. But if the opportunity cost is higher, then they will not be willing to supply it. Now, at higher prices, they're willing to do a lot of different things, such as uh, have people work longer hours, hire more help, given more money is coming in. And so they will put effort towards this idea of supplying more if the prices are higher. This is the idea of the law of supply. We can begin to apply the same concepts we did to demand, but to supply for the opposite. So if we take a look at figure 4 here, we see the willingness of gasoline supply for Shelly here. So if we go ahead and look at, so Shelly's supply schedule and supply curve show an increasing quantity of gas as the price increases, or apologies, as the price increases, the quantity supplied increases as well. So we can see, for example, from 750 is 125 to $8 is 130. So if we go ahead and keep looking at these ideas, we can see we can apply this supply schedule to, once again, to the idea of a supply curve. And how to read this curve is exactly the same as the demand curve. At $6, a person is willing to supply a quantity of 110 gallons per month. So now we get to begin to understand, what does it mean for all of the suppliers in the market to supply all of the quantities for the market. So you add them horizontally, just like you do for the just like you do for the demand. So as you can see here, we add this point, and we get this point in the market, this point and this point, and we get this point in the market. So once again, it's just adding them to get to the final price or to get to the final quantity. So now if we go back up, we're going to start talking about shifts in the supply curve. So if you see, just like the demand curve, the market, it shows at each price the quantity that's willing to be supplied. However, there are other things that can influence the supply other than price. So some of the most important ones we're just going to go over before explaining them all in depth are input prices, technology, expectations, and number of sellers. So with input prices, this is when you have prices for things that must be inputted in order to sell them. So, for example, right here, it shows that, let's see, gas. So, for gas prices, we're using the price of gas again. If oil prices, for example, increase a ton, then the supply of that is going to decrease because they are not going to be able to afford as much gas as the price that they are selling it at allows for. So remember, it is if the price exceeds the opportunity cost, then that is the willingness amount of a supplier of a quantity supplied per a price point. But if input prices get higher, then that means the the opportunity cost of supplying gasoline goes up because the price of making gasoline is going up as well. A better example might be, for example, if you were a sandwich shop and you were supplying sandwiches and the price of bread increases, then that would mean you can supply less sandwiches as a whole. Remember, this is as a whole. So the entire supply curve, if we start here and it looks like this, it's a positive relationship. And then it would shift to the left, it would go down because the quantity is going down in at every price point, which means the overall supply is going down. We talked about the difference between quantity supplied and supply, just as we talked about that for demand. And so everything is going to shift over and show that if the input prices, for example, of bread are going to increase, then the quantity supplied amongst every price point, or just the supply, is going to decrease. And then let's say that the price of bread falls. Well, then the sandwiches will be able to be supplied more because they're cheaper to make. And so the supply curve increases. So if we go like this to the right. So then we can talk about technology. So if you have good technology, then you can reduce labor costs and thus you can produce more at a lower cost. And so this allows for an increase in the quantity supplied. Another example of this would be pumps with credit card readers because it decreases labor costs. A person doesn't have to be standing at a counter and say, "Hey, do you want to buy some gas today?" And the person would say, "No, because I would rather pay with a credit card with the robot right over there who's going to replace your job." Yeah, that's right. Woo technology. So, as you can see, technology, an improvement in technology will clearly increase the overall supply. Then expectations. If suppliers are expecting that the prices will be higher later on, then that means they are probably going to reduce the quantity supplied now so that they can have a higher inventory for the future where the prices might be higher. So, for example, say I was once again back at my little sandwich shop and my little buddy told me, my little economist buddy told me that next week there was going to be a big party. And the big party encompassed the entire nation of the United States of America. And in these within this celebration, they're going to need a whole lot of sandwiches. And they said they were planning on coming over to your sandwich shop and buying a whole bunch of sandwiches. So what do? Not only are you going to start making more for the future, but you're going to withhold that supply. You aren't going to supply as much in that moment, and thus your quantity supply would go down, at least in that moment. Then, in the future, your quantity supplied is going to be dramatically higher because a lot more people are going to want to buy your sandwiches. So this is all about expectations. Same thing goes if you're expecting the prices to go down, then you're going to be probably trying to sell as much as you can now while the price is still high. Next up is the number of sellers. If there's more sellers, then there will be more quantity supplied. Not much more explanation to that. Then we get the idea of equilibrium, and this is where we get how do we find out what the actual price of a good will be? Specifically in this example, what's the price of gasoline? And how many gallons are going to be sold? So we need to put these ideas of demand, which looks like this, and supply that looks like this, and we got to intersect them. So at the intersection point, that is called equilibrium. So one combination of price and quantity at which the market is at equilibrium is at the point where the market will settle. And so this just means that all of the prices will settle at this point of equilibrium, where all of the price points which people are willing to supply and all the price points at which people are willing to demand, then at the intersection of those points is where a market, a perfectly competitive market at least, functions. And so the specific definition for equilibrium is a point at which all the forces at work in a system are balanced by other forces, resulting in a stable and unchanging situation. This is what equilibrium is. And so in econ, it's when no participant in the market has any reason to alter their behavior. So this is very important. Equilibrium is not just where supply and demand intersect, it's where nobody has any reason at all to alter their behavior. They should be happy right where they're at. So, this equilibrium happens, as we said, where supply and demand intersect. And because each of them is a different sloping line, so one is downward sloping, one is uh, upward sloping, then we can see that there's going to be only one point of intersection. So this is very important. We aren't going to intersect at all points or one point. We aren't going to intersect at all points. We are going to intersect at one point. And so if we want to take a look at an example here, figure 6 is very important in looking at equilibrium. So let's annotate this a little bit. And let's see, equilibrium, this says that this intersection of supply and demand, where nobody in the market has any reason to alter their behavior, the equilibrium quantity here for both supply and demand is going to be 10,000, and then the equilibrium price is just above $2 per gallon. And so this is this example of if we're looking at gas prices. Let me scroll up here real quick. And so we can also say at equilibrium that everyone, the buyers and sellers, are all satisfied. And this is in the sense that buyers are able to purchase as much gasoline as they'd like at a price of $2.50 a gallon, and suppliers can sell as much as they'd like at the same price. So all the buyers and all the sellers are capable of buying, maybe not willing, but capable of buying and selling, and capable just meaning it's what the price is at that specific price of equilibrium. Now, there are obviously, as we can see even looking in this chart, there are people like the people, let's say, uh, right here. And then let's actually compare each of these people. So, what it means to be at this point, right here, means that you are willing, or yeah, you are willing at a price of just below $4 to buy this quantity here. But, or you are willing to buy gas at a higher price. So you are not just willing to buy it at this quantity, you're willing to buy it at this price right here. So right here and right here, well, that's not a good example. We're going to go ahead and just look at these 2 points. So if we just look at these 2 points, then we can see that at this point, a buyer is willing to pay more than the equilibrium price would say. And at this point, the suppliers are willing to supply the good at a lower price point. Let's take a look at the counterexamples here. Let's say we have a point here and we have a point here. These people are the suppliers who are only willing to supply their good at this higher price point of $4 right here. And this point right here is all the people who are only willing to buy the gasoline at $2 and not above $2 where the equilibrium is. So this is where it's saying there are buyers who would complain about the price of gasoline. That's these people who are below the equilibrium price. And then the suppliers complain the price is too low and would want to supply it at this higher point right here. So that's what it means for it to be at this graph. Now, another important feature of market equilibrium is the tendency to gravitate towards this combination of price and quantity. So let's first, I'm going to mostly read it word for word and then I'll explain it. Suppose that the price is higher than $2.50. So if we look at figure 17, then we can see right here that the price is at $4 and not $2.50. Let's say it's at $4, and that would mean suppliers would sell 10,600 gallons. So you can see that by looking at the graph right here. We see 10,600, and then the buyers are demanding it at a much lower quantity. So this means that there is excess supply. And so no one can really, as this is saying, no one can force people to buy more gas than they want. And the suppliers at a $4 price point will see, oh, we have too much gas and people aren't buying it. And so their storage tanks filled up and there's not enough people buying gas. And so this would mean, as you can see, the quantity demanded right here is below the quantity supplied. And so we see here that both the buyers and the sellers are in kind of a rough spot here because the price for um for the buyers is too high and for the suppliers the quantity is too high. They are selling or they are producing too much. And so that's where this idea of gravitating towards quantity gravitating towards the equilibrium price and equilibrium quantity. And so we can see that if a station um, then decides, oh, let's put a lower price, then the buyers will see, oh, okay, wait a minute. We're going to go to this new gas station because it's cheaper prices. And so they're choosing uh, that to make a lower price, but they're going to gain more customers. And so then a lot of different businesses are going to have pressure to lower their prices so that they keep their customers until that equilibrium level is hit. In which case, then, if they start lowering it more, then they may not get the same profits back as they would have. And so then let's suppose the price is below the equilibrium price. So this means there's an excess demand. So with this chart, we can see that there is a greater quantity demanded than there is a quantity supplied. And this is below the equilibrium price and quantity. And so this means that the demand is higher than what the suppliers are actually supplying. So buyers want more because the price is lower, but because the price is lower, suppliers are less willing to supply such a good. So I'm going to go ahead and scroll up here. So there will be shortages. Some drivers, if there's too much demand on gas, they won't be able to find any gasoline. And then others have to wait in long lines for gasoline. And so the buyers might be tempted, as this says here, to pay a bit more money than they would have needed it to. And sellers also can see that they're willing to raise the prices without sacrificing sales. So at a higher price point, people are willing to go to that higher price point to get the quantity that they need. And at the higher price point, the suppliers are willing to supply more at higher price points, and they'll be able to supply it at those amounts because buyers are clearly more than willing to buy since there's excess demand, remember. They're more than willing to buy the gas because more people want it than there is supplied. And so if the gasoline companies just increase their supply a little bit and at a higher price point, then the customers will be willing to buy that because there is too many people that want it, and therefore at a higher price point they would be willing to take it because otherwise they might not be able to get it at all. And so this is another example of how these points will gravitate towards equilibrium here. Okay, so next up, then we see that it's only at equilibrium that buyers and sellers are having no desire to change their behavior. So it's when you have a price point above or below equilibrium that you have buyers and sellers willing to change their behavior or wanting to, versus at equilibrium level, they have no desire to. So, next we get to talk about what are the characteristics of a competitive market equilibrium. So, we already talked about how competitive markets they gravitate toward equilibrium quantity and price. So, what are the consequences of the fact that everything gravitates towards that center point, that intersection of supply and demand? Well, first, it says here that this is a very effective way of giving resources to people. And so the price is showing the potential suppliers, hey, this is what your customers are going to be willing to pay for your good. And so it gives them that information. And then also the price informs those demanders about, well, what am I giving up in order to buy this good? So what is your opportunity cost of um, that the suppliers have? So how much from a supplier standpoint, how much are demanders willing to pay? You know. And then from a demander standpoint, how much are suppliers willing to supply? And that is important for understanding uh where amounts that you can have and you can give resources to is. And so it's this kind of backhanded communication. Hey, I know what you want and you know what I want. And so we have this exchange here. And so this also ensures, this is a very important sentence, the competitive market equilibrium ensures that the available supply go to those buyers who value the good most highly. And that is provided by those suppliers who have the lowest costs of supplying the good. Therefore, it has the characteristic of maximizing the benefits of buyers and sellers receiving from the exchange. So, let's go over that again because this is very important. The available supply is going to go to all of the buyers who are most willing to buy it. So, for example, if you value gas a whole lot and say, no, I need my car, this is very important to me, and you are willing to pay for it, then the competitive market equilibrium model is ensuring that you are going to get your gas if you value it most highly. And the suppliers who have the lowest costs of supplying that good. So if a supplier finds a way to produce the good in a very easy way, then it ensures that they are going to be able to supply that good at the equilibrium price point. And so this is then maximizing the benefits of buyers and sellers from the exchange. So first, we've got to understand what are the benefits that the buyers are getting in the market. So get in the head of a buyer. It's easier for us to usually understand what does it mean to be a consumer because a lot of us are consumers. And so there is a this idea that the height of the market demand curve at every point, so remember, it's a downward sloping curve here. It shows each buyer's willingness to pay for a certain quantity. And so this shows the difference between a person who values the good most highly. So, like, if you have that right there, the person right here. So let's actually take a look at this chart right here is very useful. So we can see, actually, let's just go back to the curve because I can explain it better there, and then we'll get to that. So this person values the good more highly than this person does, or at least they are willing slash able to buy gas at this high of a price, and versus this person is only willing at this high of a price. So if we take a look here, we can see that there's an illustration here of figure 8, which we'll get to. let's say that Barb is willing to spend $100 and she's also willing to buy a concert ticket at anything less than $100. So we can see here Barb is very willing to pay for this concert. She's right here. And we can see, let's say the price is $60. Well, that means that Barb here is able to pay $40 less than she would have been able to because it's $40 less to get to 60. And then let's say there's Bob. Bob is $20 above what the actual price of the ticket is. And so Bob will be, again, just like Barb, more than willing to pay for this concert ticket here. Then there's Sharon, once again, very willing to pay for this concert ticket, would have paid at $70. So if you've ever like thought about concert tickets, right, and been like, okay, I am going to go no matter what, you would be like Barb. You would be able to, if you have a lower price point, great for you. You're saving not saving a bunch of money technically, but you are not paying as much as you would have. So if we go ahead and look at what it says here. So attending the concert for Barb produces a benefit valued at $40 for her. And then Bob has a benefit of $20. Sharon has a benefit of $10. And so if we add all of these amounts up, this is a benefit here of $70 total. And so we call this amount the consumer surplus. How much are people, well, how much are people benefiting from the exchange? If you were willing to pay more, then how much are you benefiting from the fact that a price is less? Now, if we take a look at the demand curve in figure 8, we can see that it does slope downward. And so, as the price falls, more fans are willing to purchase tickets. And along the demand curve, the height shows the marginal purchaser's willingness to pay. So remember, this idea of a marginal purchaser is literally just a single purchaser, a margin here, a a group of people that are willing to pay that price point and what is their overall benefit on that demand curve as we can see. And then I'd like to just make a note about Steve here. Steve will not go to the concert in this case because Steve was only willing to pay $50 to that Taylor Swift concert, and because he doesn't appreciate Taylor Swift as much as Barb does. And so he just decided, no, I'm not going to go to the concert because he valued it at $50, not $100. Now, I know the tickets are probably much more expensive than that, and I haven't done my research into that. So I apologize to all of you very dedicated Taylor Swift fans who know the exact prices of the Taylor Swift concerts, and I know this is a bad example, so please, I beg you, forgive me. But if we just go back here, we can see that at any point along the demand curve, the height shows the marginal purchaser's willingness to pay. So any purchaser at that point is willing to pay that amount. And so because we have that difference between, okay, price point and where is the equilibrium price, we can take the difference like a horizontal line drawn, like a difference here. So here and here, the difference, and we can see that oh wait, apologies. Oh, that was very bad. Equilibrium price is right here. Let's say a person is willing to pay right here. The difference right here is the consumer surplus for this individual. Consumer surplus for this individual. But let's say we add up every single price point all the way up to the bottom where the equilibrium price is. Now, luckily, we don't have to do calculus here if you're starting to think, oh my goodness, that's an integral. Well, luckily, Acadec isn't so, let's just say, generous as to give us problems where it asks us to integrate under the demand curve, but instead, we can just take the area of this triangle here. So if we're looking for the total consumer surplus, we can see it is going to be the area of this triangle here. And so we can find the area of this by doing the triangle area formula, right? So we have 10, and then let's just say this is like, let's just say this is 2 just for the sake of ease. We have 10 minus 2, so that's 8. And then we have right here, just for the sake of making it easy on ourselves, we're going to say this is 10,000, and then we're going to say this is 2,000, okay? So this would be 8,000. And so if we multiply, I'm going to do it down here, 8 times 8,000 divided by 2, we're going to get $32,000 is per gallon is going to be our total consumer surplus here. And so that's probably explained in these next few sections, but we can see that right here, total area below the demand curve and above the market price as a measure of total consumer surplus, total consumer surplus. And so this provides a monetary measure of how much benefit all the buyers in a particular market receive from participating in the market. So all of the buyers, they are in total getting this consumer surplus. Now, we're going to now move on to the idea of how about the producers? Are they getting any benefits from this? Of course, because it's equilibrium. So the height of the demand curve is showing the buyer's willingness to pay, whereas the height of the supply curve at each quantity supplied shows the willingness to supply of a marginal seller. So one seller in one particular price point is willing to supply goods at a certain price point, maybe even below the equilibrium cost. And so if the market price exceeds the opportunity cost here, the market price exceeds this opportunity cost of the, since the height of the supply shows the measure of the opportunity cost to the marginal seller. So remember, oh dear, dearie me. So we can see right here, this point, for example, let's say this is the intersection because I just want to draw the demand curve. We have our demand point right here. And so the market price is at like 175 or so. And so this represents the opportunity cost of producing at this price point. So we can see here, it says right here, the willingness to supply. And so at a certain quantity or at a certain price point, they're willing to supply that much quantity. And so the price or the height of that supply curve, it measures the opportunity cost to that marginal seller. So to that single seller at that single point, this price right here represents the opportunity cost of supplying the good. So this is actually very important to understand because you may get mixed up and it may ask what is representative, and you need to know that it's representative of the opportunity cost for the supplier for that single marginal seller. And then if that market price is higher than the opportunity cost, then the difference is what's called the producer surplus. So the if we take a look here, just like the demand, we can see that the supply has a difference here of market price minus the opportunity cost for the producer. And so we can see here that let's say I'd like to do an easier one. So 50 and 175. So we see the difference here is 125. And we can see here that for this marginal seller, there are $125 in benefits for this supplier. But let's say we want to take a look at the total producer surplus. We know here that it's the area of this under triangle now. Now, we can then add up all the little lines and we get 350 times 175, and therefore 75 times 350. Do I have my handy dandy calculator with me real quick? Let me let me see if I can go ahead and get it. Go ahead. Now, you'd have to do this in your head on the actual test, but you know what? I'm going to cheat for the sake of time. The total producer surplus is $61,250. And so we can see that this is the total producer surplus. And we can do this with the area once again. But we can also add the consumer surplus and producer surplus, and we get all of the total benefits that all market participants receive. And this is called the total surplus. So we're adding up both little triangles in the curves here. And so a benevolent social planner should be trying to maximize this combined surplus. And since this outcome produces the greatest overall good, then they should be maximizing it. Greatest overall good means that we're going to be wanting to try and maximize this surplus as much as possible. If you maximize this total surplus, then we can say that we are satisfying Pareto efficiency. Remember our discussion of Pareto efficiency. We are giving out resources to where giving resources to one person is taking away from another. So all of the resources that we have are being put to use. And so we are at Pareto efficiency there. And so it puts it very nicely here where it says there is no way to make anyone better off without reducing the welfare of someone else. So maximizes total surplus, satisfies the economist's criterion of Pareto efficiency. So maximizing total surplus, I'm going to write this as an equation. Maximizing max total surplus equals Pareto efficiency. So when you have max total surplus, then we are Pareto efficient here in the market. Now, let's see what actually, let's look at a market equilibrium that meets this efficiency criterion. So we're going to look at something that maximizes the total surplus, such as in figure 10. So we can see right here, this is Q1, just so you can visualize, and this is Q2. And now we're going to go ahead and read what it has to say about that. So Q1 is less than the equilibrium quantity. And so at this point, the value of the good to the buyers, it exceeds the cost to the sellers supplying the good. So remember, the point of a quantity right here is the opportunity cost to the supplier. And this is how much the consumer is willing to pay. And so the consumer willingness to pay is greater than the producer's opportunity cost. And so this would mean that both people could have an overall benefit, uh, could have increased benefit if you just increase the quantity. So any point to the left of the market equilibrium can't be efficient because both parties would have a benefit if they increase the quantity supplied. Then at Q2, so remember what we saw here, Q2 at a point beyond the quantity at equilibrium. Then what we have here is an amount greater than the equilibrium quantity. And so the supply curve is above the demand curve, which means the cost for producers to produce that much of the good is going to be higher than what consumers are willing to pay for it. And so this exchange isn't happening voluntarily. It doesn't happen in markets, at least in free markets. And if it did take place, then buyers and sellers would be suffering a loss in welfare. And so, like, I imagine this as if there were some, let's just say, like a communist dictator here that was saying, no, no, you must supply this quantity. And I don't care if you consumers can't afford it and you producers must produce it at this much. I don't care. You're going to do it my way because I'm a communist dictator. Please do not quote me out of context like that. Although maybe it wouldn't be such a bad thing. Anyways, it can't be accomplished voluntarily. So a market planner needs to then know where is each consumer placing their value. And so how much do they value the good at? And how much does it cost to produce each unit? And this determines how much should be produced and by whom and to whom it should be given. So who's making it, who's giving it, this is all determined by knowing what's the value of the good in question and knowing how much it costs to actually produce. And so this is actually a very difficult task. If you had to be a market planner, if you were planning, okay, what does every single person value this good at, and what does every single producer have their cost of? But a competitive market simply just takes into account what are the self-interested actions of its participants. So if we look in self-interest, and we only respond to signals provided by the market price. So the market price, remember, is signaling what consumers value at, the good at, and what producers, their opportunity cost for producing at that amount is. So next up, we get to talk about well, how do we actually apply the competitive market model to what we see in the world? So, with our newfound knowledge of supply and demand, with finding equilibrium price and quantity in a competitive market, we can now make predictions. Predictions based on how the shifts in an economy affect a market as a whole. So, we're going to start by just looking at analyzing issues related to this competitive market. So, one of the key features of a modern competitive market is technological process, so making new technologies. And so, because the new inventions of today are being continually made, this allows for suppliers to supply goods at lower costs. And thus, we can then increase social welfare, as we're going to get into later. But one example of this is the synthetic bovine growth hormone. So this allows dairy farmers to increase milk production by between 10 and 20% at a very low additional cost. So remember what we talked about earlier, introducing new technologies allows for a shift in the supply curve, a shift rightward, an increase in supply as a whole. And so this is shown here in figure 11. So we see that the supply curve has shifted over to the right. And so technology usually has other effects on a market called externalities. And these aren't immediately noticed by an analysis of a market, but we will later discuss externalities and how they affect a market as a whole. But just for now, keep in mind that externalities are extra effects that new technology, for example, new technologies could make. And so if we take a look at this market here, we see a market of equilibrium before BGH. So we have our total surplus all right here. And then we have our market equilibrium. And this is the supply curve here of this. I believe this is the supply of milk in gallons. And so once the BGH was introduced, the quantity of milk at any price supplied is going to be increased here. So we see this increase right here. And so we see that it has shifted to the right. And so what we can see from this is that the demand intersect moves down along the demand curve from point A to point B. So if we look at this, where is it moving? The point is moving down. So the price has therefore dropped and the quantity has thus increased. And so we are then at this point for the equilibrium where the equilibrium quantity has increased and the equilibrium price has decreased. And so it's also clear the total surplus has also increased and consumers are unambiguously, so that just means everyone is better off, as unambiguously better off because of the innovation. And so it's because of this shift rightward that we see that there's this increase in area right here, or actually all of this too, for the consumers, right? And then we've got this for the producers, which although we've taken away some of the producer surplus, overall, it's a benefit overall because we added all of this. So for the consumers, this is the increased consumer surplus. But as a total, I'm gonna actually change color. The red here is total surplus. This little triangle, this total new surplus is the increased social welfare here. So we can see that the lower price consumers can purchase additional quantities of milk. And the effect on producers, it can be more ambiguous. So by unambiguous, it was meaning it's very clear. It's very clear that the consumers are gaining more because of the innovation. And then the producer surplus, it's kind of hard to tell. And so, because the increase in sales has caused an increase in the producer surplus, but the lower price reduces the producer surplus on that new quantity that was previous or that quantity that was previously used. So now that the price is lower, we're getting more quantity that we're selling, but our price is lower. And so whether the producers or the consumers benefit all depends on how much is the consumer surplus increasing and how much is the producer surplus decreasing, or the other way around. How much is the producer surplus increasing and the consumer surplus decreasing, or maybe both uh, increasing by a shift of both curves. And so we could also look at an example of public health. And so we can see that if public health officials are seeing that cigarette smoking is harmful, and so we want to reduce smoking. So one approach is to reduce the demand for those cigarettes through public education campaigns and lists, warning labels on packages of cigarettes, and we can see that, okay, let's say that this decreases demand. Remember, this would be a sort of tastes sort of thing. If you have a change in tastes, then your demand curve here is going to shift to the left. And so the effect here we can see in figure 12. So if we go down to figure 12 here, before the cigarette campaign, this was our, oh, let me go ahead and scroll down. We can see that this is our intersections. And if demand goes downward this way, go ahead and just scroll, then we can see that the new demand curve is down here and our new price is now lower and our quantity is also lower. And so based on this, we can make a few conclusions. So we can now understand that seeing this both the equilibrium price and the quantity both decrease. And so we're able to see that a quantity supplied and demanded is less for cigarettes. And so we are then using this as a market model as a whole. And so next up, we get to start a talk about elasticity. So this will be very fun to talk about. So in our discussion of elasticity, we're going to be defining, well, what is elasticity? So we've started to get this idea of what is a competitive market model and how are we going to predict where the equilibrium, price and quantity is going to be changing and how it's all changing in relation to market supply and demand. And so we need to understand, however, how much of a change is happening given changes in price. So how much of a change in quantity of either supply or demand is happening given a certain price change. And so this is where we start to get the idea of price elasticity. So the price elasticity of demand, it measures how much of the quantity demanded responds to a change in price. So you can think of this in other terms of as if it were a slope. So how much is one thing changing in relation to the other? Except one really key thing to notice about elasticity is that it's the quantity demanded, the percent change in quantity demanded divided by the percent change in price. So if we're looking here, let's say, we'll get to that. Let's say we look at this right here, this equilibrium. We have this line right here. So we know the slope here is very negative. We could say this is like negative, like, I'm going to make up numbers, -10. But the elasticity is actually going to be very low because instead of where slope, we have the change, delta just means change, change in y, delta the triangle, it means change. And then delta x is going to be very small. So we know that the percent change in the x divided by the percent change in the y is equal to the elasticity. So we it's the opposite of slope. So that means we have right here a low elasticity because for any given change in price, let's say from 5 to 4, we're going to have or actually even 5 to 2, we're going to have a very minuscule change in the quantity here. And so this is important when understanding what is our elasticity actually representing. So remember, the law of demand, it's saying that it's the price and the quantity demanded are negatively related. So we can actually, with elasticity, ignore of um, the sign of the slope because we know it's always going to be negative. We know the demand curve always goes downward. So we don't need to be worried about the sign itself, but instead we can just take the absolute value, which is just making it positive. And so the formal definition here is it reflects how responsive consumers are to changes in the price of a good. So if something is uh quite is highly elastic, let me scroll up here. So if something is highly elastic, that means that the consumers are going to change their demand a lot based on a change in price, in a given change of price, versus relatively inelastic is when you have a relative or you have a set change in price and it changes in quantity very little. So demand is said to be inelastic if a 1% change in price results in a less than 1% change in the quantity. So if the price changes by 1%, that's your marker, is 1%, and the quantity demanded changes by less than 1%, then, excuse me, we're going to have an inelastic demand. So not only demand, but there's also elastic demand here, which I kind of skipped over. A 1% change in price results in a greater than 1% change in quantity. So that's elastic. And then if we go up here to unit elastic, is if a 1% change in price results in a 1% change in quantity demanded. So percent for percent, it all changes up. And something to note is that it's in percentages. So when doing math problems in these, we need to keep in mind that this is a percentage. So you can't just say, oh, it changed by 5 uh, gallons of gasoline, the quantity demanded, and there was a change in $1 of price. That doesn't work because it's not a percentage change. You need to take into consideration how much is being changed relative to the others. So elasticity is important here because it measures the responsiveness of demand. So this means that um, it's it's how much the quantity demanded is changing based on change in prices. And so it's independent of units of measurement. And so that may be important to remember for tests, is it may be just a simple question where it's asking, um, what is um, elasticity not dependent of, and that would be units of measurement. It doesn't have any units. And so we can see that the slope, if it were for gallons of gasoline, would be in gallons, but the elasticity will just be the same. And so there's a different slope for like liters or gallons, whereas the elasticity is going to be the same no matter what because um, the quantities don't matter as much as the percent changes do. And so we can actually see next, looking at what are the factors that influence the price elasticity. So these factors, I'm going to go through them and then I'm going to explain them. So there's substitutes, necessities, market definition, and time horizon. So these are important for realizing that these are for the elasticity of demand only. We will get to the elasticity of supply later, but note, substitutes, necessities, market definition, and time horizon all have to do with the price elasticity of demand specifically. So, what are how do substitutes impact elasticity? Well, if we have goods with close substitutes, then they're going to have high price elasticities of demand because consumers can switch easily from one product to the other. So, for example, let's go back to bread and bagels. So, if we have bread and we have bagels, and we have let's say that the bread increases in price by a ton, or not a ton, only a little bit, right? Because we have the close substitute of tortillas, then we are going to be more willing to just stop buying bread and go and buy more tortillas with every incremental change in price. So then let's take, for instance, something that is a little harder to change from. And let's say it's a cell phone. So let's say you're a really heavy Apple user, and there's not very many close substitutes to an iPhone specifically. And so if the price increases for an iPhone, you might try and go look for an Android phone. But if you are specifically in the market, and this will get into market definition, but if you are specifically in the market for iPhones and the price increases, you probably aren't going to be able to find many close substitutes for an iPhone. So you're just going to kind of have to deal with it and pay the price. And so that would be a lower elasticity. So if there are no close substitutes, then the price elasticity will be lower. Then we have necessities. If you have a necessity, items regarded as necessities usually have a lower price elasticity of demand than luxuries do. Because if people have to drive, for example, then the demand for gas is more than likely a low price elasticity because a change in price of gas isn't going to change very much how much gas you're consuming. You need to drive anyways, so you're gonna consume it anyways. So you have a low elasticity. So once again, if we were to go back to this chart here, this here is a perfect example for like let's say gasoline even. So if the price increases from 3 to 5, our um, our quantity demanded actually only changes by this tiny amount right here. And so that's a low elasticity. Versus if it's a luxury, then we can see it's something that's not necessary but nice to have, then it's going to have a higher elasticity. price elasticity of demand specifically. Then we get into market definition. And so the price elasticity of demand depends on how we actually define the market. If if you have a broader market definition, then there are going to be fewer close substitutes. And then uh, you will have a lower elasticity of demand with fewer close substitutes. So if you just take soda as a whole and say, here is the price elasticity of the demand for all soda, there's not very much substitutes for soda. I mean, you could go over and maybe say like juice or something, but that's the closest substitute, really. And that's not really, you still want your soda. Versus if you say, okay, specifically for, let's say, a specific brand of Coca-Cola, okay? If you say, I, what is the elasticity of demand for Coca-Cola? That is going to be a higher elasticity because people are more willing to switch over from Coca-Cola to, let's say, Pepsi if the price of Coca-Cola goes way up here. And then we have time horizon. So if we have a short amount of time, then people are unable to change their tendencies as quickly because they have less time. So in the short run, if gasoline prices skyrocket, then people won't have much time to adjust and stop buying gas. And so the elasticity will be inelastic because the change in the quantity demanded of gasoline, the percent change is going to be less than one relative to a 1% increase in price. So then, however, if we have more time on our hands, then we're good to go. We don't even have to worry too much even about gas anymore because let's say we have a ton of time, well, then I can spend time saving up money for, say, an electric car, and then I don't have to rely on gas anymore. So we can look for other or even fuel efficient cars. And so this will reduce the demand for, I mean, this will reduce the price, no, increase the price elasticity for demand because people are more willing to get out of the market for gas and therefore decrease the total quantity demanded. So, as I talked about earlier, the elasticity is very much a big part of the slope of the demand curve. And so the curve is flatter if it has higher elasticity. So flatter curve equals higher elasticity. And a linear, along a linear demand curve, elasticity is falling continuously. So this just means that the elasticity is decreasing as you move along a linear demand curve. And so we can see that elasticity falls with quantity and price. So what they do here is they do a bit of math. So I'm going to try my best to walk you through the math of this. And that is, we know that it has a constant slope. So delta P, which is the change in price, divided by the change in quantity. This is the physical numbers, not the percentages. This is change in price divided by change in quantity. Let's say equals this letter E, this random variable that we're assigning it. Now, we can say that if we swap this, we have change in quantity divided by change in price. This equals 1 over E, just this constant. It's just a number. We don't know what the number is, but it's just a constant. And so we know then that the elasticity of demand is equal to this constant right here we know because it's linear, it's constant, this 1 over E. And so in order to get the elasticity of demand, we are multiplying this constant here, this constant slope, by the, so we are multiplying the change at a, on along the line, since it's constant, by the actual ratio of the price over the quantity. So this is how we find the elasticity of demand. And so if we continually move down, we see that P, the price here, it decreases and the Q increases. So this means that the ratio between P and Q, if this lowers and this rises, then this is going to be a lower number. And since we know that 1 over E is a constant, then we know that because P over Q is decreasing, we know the elasticity is then falling as well. And another thing of note is that we can see that the change in quantity over the change in price is, we know, the slope. And so it is that conversion to a percentage that allows us to measure that demand. So just honestly, just memorizing the fact that the price over the quantity times the change in quantity over the change in price is equal to the elasticity of demand, and that the elasticity decreases along the linear path, then you should be okay for the test. So I'm going to try and explain this in one more way, and that is thinking about, well, what does it mean for there to be a percentage? So if we think about percentages, let's say we have a quantity of, let's say, like 1 gallon of gas, right? And we're changing by 5 gallons of gas every day, let's say, or month per month, right? So in order to find the percent change in gallons at any given point, we can see that, okay, well, we're at 1 gallon, and if we're increasing by 5, that would mean we do 1 times 5 equals we increase by 5 gallons, which, notice, this is 1 times 5 is 5. 5 is 500% of 1. And so our elasticity here is 500% because we see here that it's 500% of 1. We're increasing it by 500%. And so notice this is just another way of saying, okay, apologies. It's actually dividing. We have 5 divided by 1, right? Because this is how much is it changing by divided by the original amount. And so this is 500% then. Usually multiply by 100% in order to get that. And so that's where this change in quantity divided by quantity times the price, or yeah, the price over the change in price comes from, because you're trying to see the ratios here. And so the main point here, though, if you want to just have a basic understanding of it, is understanding that when there is a linear relationship of the demand curve, then the elasticity is falling as the line falls as well. Now, we are now going to discuss what does it look like for there to be different elasticities. So we can have perfectly inelastic, which shows that quantity demanded does not depend on price at all. You just have a fixed amount, a quantity that does not change based on price. So let's say price goes down, well, the quantity doesn't change at all. Then we have inelastic, which is when it hardly changes. Unit elastic, when it changes by 1% for 1%. And then elastic, more than 1% for 1% change in price. And the other extreme case is perfectly elastic, in which the demand curve is perfectly flat. There is going to be, well, in a way, just mathematically, an infinite change for any change in price, when in reality it's just known to be completely flat and will change no matter what, pretty much. But we can see that in a perfect inelastic scenario, we're not changing the quantity demanded based on the price. And then with inelastic, we can see that there is a lower change for quantity than there is for price. Unit elastic here, we have for the change in quantity, the percent change is the same in the price. And then elastic is when the price goes up by a bit, the quantity will change by more percentage. And then we scroll down and we see perfectly elastic demand, where the elasticity equals, as we said, infinity. And so at $4, consumers will buy any quantity at all. And if the price is above $4, they will buy none. And if the price is below $4, they will buy an infinite quality. So as we can see, this is kind of an unrealistic scenario here, but understanding each of these captions is pretty important too, because if there's an increase in price, there's going to be no change for inelastic, for perfectly inelastic. And then for just inelastic, a higher percent change in price will lead to a lower percent change in quantity. And then unit 22 will lead to 22. And then elastic 22 will lead to a higher number, in this case, 44. And remember, these are all relative to the demand curve. So it's all going to be a decrease, for example, when it comes to increase in price, but always an increase when there's a decrease in price. And then the elasticity equals infinity, of course. They'll buy any quantity at $4, price above $4, they'll buy none. And if the price is below $4, they'll buy an infinite quality. So it's kind of unrealistic, but that's what it is. So next up, we can talk about the elasticity here of supply. And so it's very similar to elasticity of demand, where the percent change in the quantity supplied is divided by the percent change in price. So opposite slope here. And we can see that it it shows the ease at which suppliers can change the quantity. So changing, let's put a little delta there, the quantity of production. So how much are we changing, how much we're producing, given a change in price. And so here are a few factors which influence the responsiveness or elasticity. Now, you may be asked a question as well as which word is most similar to elasticity. And I would say the best option for that would probably be responsiveness. So, how much is something responding to a change? Now, let's go over these factors and then I'll explain them in depth. So, we have ease of entry and exit, scarce resources, and time horizon. So, notice these are different from the price elasticity of demand, which, can you recall them? They were, once again, we had the same thing here. We had time horizon, we had market definition. Can you complete a couple others? Can give you a little bit of time to think here. So far we have time horizon, market definition, close substitutes, perhaps, or yes, close substitutes. And there was one more. I'll go ahead and show it. Necessities. So we have those four, but we only have three when it comes to the price elasticity of supply, and that is ease of entry and exit, scarce resources, and time horizon. So, ease of entry and exit. If people can easily start supplying a product, then the supply is more elastic. We can more easily supply more for higher prices or for incremental changes in price. More people will be more willing to supply those. Now, it is if it is easier to leave, then that means that for a lower price, a or a lower price decrease, then people are able to supply less considerably. And so, for example, the supply of airline flights is quite elastic. So, for a specific route, because the airlines can just shift the planes from one route to another to respond to changes in prices. So if uh, if you have a price increase to a another location in an airline flight, then you are going to be able to shift over to that location instead of where you were originally going to be flying because you have the airplane anyways, and so it's easy to enter that new route instead of and exit the old route. And so in response to the change of prices, it's clear that airline flights will be elastic. Then we have scarce resources. So if we have only a little bit of goods, like for example, the bread in the sandwich making example, then we will have different uh, price elasticities of supply. So, for example, it talks about here a or a bunch of beachfront vacation homes. These are highly inelastic because all of the beachfront property is limited. All of the beachfront property that you can ever buy it's fixed. You can't change the amount of beachfront property there is unless you build more, of course. But in a shorter time horizon, then no, you can't change that. You just have a fixed amount of supply and the price, no matter what it is, you're you have that much supply and it will not change. Even if the price increases, it's hard to be able to build new beachfront properties. And so that is then inelastic. Versus elastic would be, let's say, uh, a lower input price and you have like a ton of bread that you can make, then you're going to have more elastic because you can more easily make more goods based on an increase in price because you have low bread prices. And then we have time horizon, where if we have a longer time horizon, then we're going to have a greater elasticity of supply. And so over shorter time horizons, the firms won't be able to hire or train additional workers or even add to the necessary equipment. So that would be relatively inelastic if you have shorter time horizons versus longer time horizons will have more elastic because you're able to change the quantity more based on how much you have. And so, just like with price elasticity of demand, if the supply curve is flatter, that means it's more elastic. And once again, we can have perfectly inelastic and inelastic, unit elastic, elastic, and perfectly elastic for each supply. So a good example of perfectly inelastic would be Van Gogh sunflower paintings. They aren't going to change because Van Gogh, unfortunately, cannot paint anymore. I mean, of course, he could always come back and decide, you know what? Nah, I'm gonna define all those people that say I can't paint because Just gonna rise up and be like, I'm still a painter, guys. And so we can't really have him paint anything anymore. And so we have perfectly inelastic supply. So we're gonna go ahead and go and scroll down to figure 14 here. Oh dear, that was much too much. So we can see here that perfectly inelastic supply is when the elasticity equals zero. So a 22% increase in price leads to no change in the quantity supplied. 22% increase leads to 11% increase in quantity. So not very much. And then we get here to unit elastic, where 22% increase leads to 22% increase. And then 22% increase leads to 44% increase, which is a higher increase, is elastic. And then finally, we get to the weird one, the perfectly elastic supply, where producers will supply any quantity demanded at $4. And if the price is above, this we'll have an infinite amount of supply for that good. But if it's below, then the supply will be zero. So this is actually opposite to the demand. Remember, with demand, it was below, then we'll have an infinite demand. If it was above, then we'll have zero. But in this case, we have if it is below, then they will supply an infinite amount. And if it is above, then they will supply none at all. Or, I mean, other way around. Below, zero. Above, infinite. This is for supply. Versus demand is the opposite. Say we have a demand curve here, or at least a perfectly elastic demand. Then below is infinite and above is zero. Because, I mean, this makes logical sense, right? Because if we have a price above, then nobody's going to want to pay for it. Versus if we have a price below, well, then, oh, everyone's going to want that because we have perfectly elastic here. And then nobody's going to want to supply at a lower price than 4 when we can supply anything at $4. And then everyone's going to want to supply when there's a price higher. So there's this difference here. Okay, so next up, we get to talk about how do we actually use elasticity. So let's talk about bovine growth hormone. So bovine growth hormone is this starting point for understanding what does it mean for there to be total revenues available to producers in the market. So how do we find total revenue? Well, most people usually know this, but it is price times the quantity here. So we have price times the quantity, and it can be shown in figure 15 here. If we just go ahead and scroll all the way down, all these figures are so spread out, we can see total revenue is just the price times the quantity. So the total revenue here for milk is going to be $4,000. And so it's the area of this little box. And so if we go back up here, then we can see that if the demand is elastic, then the total revenue will increase as the um, price decreases. So if the price decreases and the demand is elastic, then the total revenue will increase. So I'm going to say that again because this is important. Elastic demand. So you have this demand curve here, where along each point you have a price and a quantity that a person is purchasing, right? If you have elastic demand, then as you go down, then you are going to have an increasing amount of revenue because it is the change in quantity is greater than the proportionate uh, increase in price here. So if the demand is elastic, total revenue will increase since the proportionate change in quantity will be greater than the proportionate increase. I think that should be proportionate decrease in price. I think it even shows it in the figure here. So because we have a an inelastic demand here, we have a revenue decline after a fall in price. And so I do believe it may be written wrong here. So if it's inelastic, then the total revenue will decrease it when prices fall here. Yes, and looking more into it, this right here, it should say decrease in price. So if the demand is elastic, then the total revenue increases as the price decreases. But if it's inelastic, then the revenue will decrease. So we're going to go ahead and walk through an example here and see that if we're looking at the demand for milk, we know that milk has a relatively inelastic demand. And so we know this because it doesn't have a lot of close substitutes and it's a necessity. And so that means it has relatively low price elasticity of demand. And so we know, though, however, that the supply of milk is relatively elastic over a time horizon of a year or more. So when we have a large time horizon supply of milk, the elasticity is not very hard to have. So it's a relatively elastic supply. And so we can see that the demand curve for milk is going to be drawn inelastic in figure 15 here. So we see it's relatively inelastic. And we're going to do a bit of math here where we explain, okay, so what is the elasticity, first of all? And then second of all, how much is it decreasing? So we can see that I'm actually going to go to this chart right here. So our original amount was 2 and 2,000, if you remember. So our revenue right here was $4,000. And notice that our total revenue has decreased. So this is implying already, if we already know this, that this is going to be an inelastic demand. So you need to connect those ideas because it might say, oh, there was a decline in revenue. What does this imply? Well, it implies that there is a an price or inelastic demand. Yes. The price elasticity of demand is inelastic. And so we can also calculate this by literally doing the math here and seeing that, okay, a change from $2 to 150, okay, and then we know the quantity has changed from 2,000 to 250. So we know this is a decrease and this is an increase. And we know it's going to be the percent change in quantity divided by the percent change in price. And so what's the percent change here in quantity? Well, 2250 minus 2000 divided by 2000 is going to be our change here, which if we go ahead and just do a little math here, we know it's 250 divided by 2000. And we then know that's just going to be 0.25 divided by 25 divided by 2, which is 0.125, which we know is 12.5%. And then a percent change in price, well, if we have 1.5 minus 2 divided by 2, that's going to be a negative 0.5 divided by 2, which is negative 0.25, which if we divide by negative 0.25, apologies, it's just going to be then 25%. So negative 25% and negative 50%. And so that's what we have, or not negative 50%, apologies. It's just negative 0.5. Well, I guess it's the same, negative 50%, but negative 0.5 is the elasticity here. And so we can see that this number, it is below zero, or no, it is, it is, the absolute value of it is below one. And so we already knew it was going to be negative, right? Because for anything with demand, it's going to be negative. But 0.5, the absolute value here, is less than 1, and so we can imply then that it is inelastic. And so if it was greater than 1, so say like 1.5, then we would know that it is elastic here. And so we just went through how to solve for elasticity and overall how this impacts revenue. And so it looks like if you have BGH here, then remember what we said earlier is the BGH will shift the supply to the right. So let's say that this line here was our original supply, and then afterwards we have BGH and it shifts to here. So our original revenue was here, and we know we're going to have a greater revenue right in this giant box than we will in this new box because it's relatively inelastic. And so we see that the farmers, by introducing BGH, are decreasing their overall revenue. And so why would we ever want to introduce something that decreases our revenue? The real answer is just they have no choice. Every farmer only supplies a small amount of the total output. So for all of the milk in the world, a farmer only supplies a little bit of it, a single farmer. And overall, if they use BGH or not, doesn't impact the price because if everyone else uses BGH, then the price is going to be lower anyways. And so it's because of competition and the ability to even supply milk that drives them to use BGH. And then as farm revenue falls, some farmers may just stop producing the milk. And so this allows those farmers who remain in the industry to keep or increase their standard of living by producing a greater quantity because with less competition, they'll be able to produce more for their customers. And so this has actually happened in the last 200 years in the farm sector, where we can see that technological innovations have increased the ability of farmers to produce more crops, although this has been coupled with the decline in farmer numbers overall. So that was this section, and next we're going to be able to talk about evaluating government policy and government policy as a whole, and how that impacts a lot of what we've even still been talking about, supply and demand.